Hello, good morning. In this class, we solve some more important problem of based on moment of inertia. First question is problem is given the determine the to determine the polar moment of inertia of I section as shown in given figure. Figure is given of I section of top flange. Size of the top flange is 1880 by 12. All dimension are in millimeter, so 18 millimeter by 12 millimeter, and bottom flange is 120 millimeter by 10 millimeter, and total depth of the I section is 150 millimeter by 12 millimeter. This 12 millimeter thickness of the wave. So first we have to find out the depth of the wave. What is the depth of the wave? First we need to find out the depth of the wave. Depth of the wave is equals to total height of the I section, depth of the I section minus thickness of the top flange and thickness of the bottom flange. So 150 minus 150 minus 12 minus 10 is equals to 128 millimeter. So we have to calculate. So we calculate the depth of the wave of this section. So calculate the polar moment of inertia. What is the polar moment of inertia? Polar moment of inertia is moment of inertia about z axis. Z is the pole, which is equals to moment of inertia about x axis plus moment of inertia about y axis. So we need to find out the CG about x axis and CG about y axis. We not need to find out the CG about CG about y axis, which is symmetrical. About the section is symmetrical about y axis, so CG will be passed from the center of the CG will be passed through the center of the I section about y axis. We need to find out the y bar, which is CG about the x axis, CG about x axis, y bar. So y bar is equals to, we know y bar is equals to a1 y1 plus a2 y2 plus a3 y3 plus so on, divided by a1 plus a2 plus a3 dot so on. So choose a section. This is the section 1 and this is section 2 and this is section 3. Let me draw clearly. So it will be easy to understand. It will be easy to understand. This is the I section. This is the section 1. This is the section 2 and this is section 3. So we need A1, area of the section 1. A1 is equals to length into breadth. Length is the 80 into 12 is equals to 120 millimeter square. Area of the section 1 and area of the section 2 is equals to A2 equals to 128 into 12. 128 into 12, and area of the section 3 is equals to 120 into 10. 120 into 10 is equals to, it will be 1200. Sorry, A1 is equals to 80 into 12. 80 into 12, which is equals to 80 into 12, which is equals to 960, sorry, 960 millimeter square, and area of the section 2 is equals to 128 into 12, which is equals to 1536 millimeter square. So find out the y1 and y2 and y3, y1, y2 and y3, y1, y2, y3. Let me find out the from base. From the base, y1 is equals to center of the CG of the top flange to from CG of the top flange to the base, which is equals to y1 is equals to what? Y1 is equals to 150 minus 12 by, this is 12, total height is 150, and this is the thickness of the top flange is 12, this is equal to 12 by 2 is equals to 150 minus 12 by 2 is equals to 144 millimeter. This is 144 millimeter, and y2 is equals to center of the wave to the base of the I section, which is equals to y2 is equals to total depth of the wave is equals to 128. So 128 divided by 2 plus thickness of the bottom flange plus thickness of the bottom flange is 10. So 128 divided by 2 plus 10 is equals to 74 millimeter from the base of the I section, and y3 is equals to obviously 10 by 2. y3 is equals to obviously 10 by 2 is 5. 10 by 2, this is equals to 5 millimeter. So y bar is equals to put the value of in this equation, put all the value in this equation. A1 is equals to 960 into y1 is equals to 144 plus A2 is equals to 1536 into y2 is equals to 74 plus A3 is equals to 1200 and y3 is equals to 5. Total whole divided by A1 plus A2 plus A3. A1 plus A2 plus A3. This is 960 plus 1536 plus 1200. This is equals to 960 into 144 plus 1536 into 74 plus 1200 into 5 divided by 960 plus 1536 plus 1200, which is equals to 69.78 millimeter from the base. So we find the CG of the I section is equals to 69.78 from the base. Let me draw the section, I section. So here is the CG passing this, sorry, CG about x axis, y axis, which is equals to y bar is equals to 69.78 and about y axis, this is about x axis, y bar is equals to about x axis, y bar is equals to 69.78, and about y axis it will be center of the section. Say this is x, this is x, and this is y axis. This is x axis and this is y axis. We have to find out the first, we have to find out the moment of inertia about x axis, which is passing through the CG, about x axis, which is I x is equals to moment of inertia top flange, which is equals to I x1 plus moment of inertia of the wave, which is equals to I x2 plus moment of inertia of bottom flange section 3, which is equals to I x3. Now first we have to calculate the moment of inertia of top flange x1 is equals to moment of inertia of, this is the shape of the rectangle or rectangle, plus area of the rectangle A1 into H1. What is the H1? H1 is equals to from the center of the top flange to the CG of the whole section. This is the H1. H1 equals to H1 equals to H1 equals to y1 minus y bar. What is the y1? From here to here is the y1. This is 144 minus y bar. Y bar is equals to 69.78. 144 minus 69.78, which is equals to 74.22 millimeter. So H1 is equals to total from CG of the top flange to base is equals to y1 minus from CG to the base of the from the CG of the whole section to the base is equals to y bar, which is y1 minus y bar is equals to H1, which is equals to 74.22. This is equals to 74.22. Moment of inertia of rectangle section about CG equals to, we know, B d cube divided by 12 plus area of the section 1 is equals to 960, which is equals to 80 by 12, 960. Already we have calculated 960 into H1 equals to 74.22. B is equals to 80 into D equals to 12 Q. This is the 80 and this is 12. 80 into 12 q divided by 12. So 80 into 12 q divided by 12 plus 960 into 74.22. This is equals to 8277.1.2 unit is millimeter to the power 4. The moment of inertia about x axis of top flange is equals to 8277.1.2 millimeter to the power 4. In briefly, I have write the h1 is equals to y1 minus y bar is equals to, which I calculate the 144 for minus 69.78 is equals to 74.22, and h2 is equals to what? h2 is equals to center of the wave, from center of the wave to base, center of the wave to CG of the whole section. Let me, the center of the wave is here. This is the h2. h2 equals to what? h2 equals to y2 minus, from here to here is y2 minus y bar, y2 is equals to what? y2 is equals to 74 minus y bar is equals to 69.78, which is equals to 74 minus 69.78 is equals to 4.22, which is equals to 4.22 millimeter. Now calculate the CG. Calculate the CG distance of section 3, which is equals to h3 is equals to center of this section bottom flange from the CG of the whole section is equals to h3. h3 is equals to y bar minus y3. Y bar is equals to 69.78 minus y3 is equals to 5. 69.78 minus 5 is equals to 64.78 millimeter. Now calculate the x. Now calculate the moment of inertia about x axis of wave. X2 is equals to moment of inertia of this rectangle of wave section plus area of the wave section into h2 square. Say this is 1 so b2d 2 cube divided by 12 plus a2 into h2. What is the b2? b2 equals to thickness of the wave. b2 is equals to thickness of the wave. Thickness of the wave is given 12 millimeter. So thickness of the wave is equals to 12 millimeter into depth of the waves. Only depth of the wave from here to here is equals to 128. Here depth of the wave is 128. 128 cube divided by 12 plus area of the section 3, sorry, area of the section 2 is equals to, area of the section 2 is equals to 1536 into h2 square. What is the h2 square? h2 is equals to 4.22 into 4.22 square. Sorry, this is h1 square, so means 74.22 square. 74.22 square. So it will be change. Let me calculate this one first. 80 into 12 cube divided by 12 plus 960 into 74.22 square. Sorry, this is equals, this will be 5299784 millimeter to the power 4, and this will be, calculate this one for the wave section. 12 into 128 cube divided by 12. 128 cube, 12 is cancelled, 128 cube plus 1536 into 4.22 square. This is equals to 2124505 millimeter to the power 4. Now calculate the moment of inertia of section 3, that means bottom flange. 3 is equals to b3 cube into, sorry, b3 into d3 cube divided by 12 plus a3 into h3 square. h3 square. This b is equals to width of the bottom flange, and d is equals to depth of the bottom flange. B equals to 120, I think it's 120, yes, 120 into d equals to 10, d equals to 10 cube divided by 12 plus a3 is equals to 1200 into h3 is equals to here 64.78 square. Ten cube into 120 10 cube into 120 divided by 12 plus 1200 into 64.78 square, which is equals to 5045738 millimeter to the power 4. So moment of inertia about x-axis of the I section will be total moment of inertia Ixx is equals to Ixx1 plus Ixx2 plus Ixx3. Now calculate the total moment of inertia. Ixx is equals to Ixx1 plus Ixx2 plus Ixx3, which is equals to moment of inertia about x-axis of top flange is equals to 5 to 99784 plus ix2 is equals to 2124 500, sorry 505 plus, and section 3 is equals to 5045738. Let me around into 10 to the power in 10 raised to power or something 10 raised to power 6 5.29 into 10 to the power 6 plus 2.12 into 10 to the power 10 raised to power 6 plus 5.04 into 10 raised to power 6. So 5.29 plus 2.12 plus 5.04 is equals to 12.45 into 10 raised to power 6 millimeter to the power 4. This is the moment of inertia about x-axis. Now find out the moment of inertia about y-axis. It will be very simple to calculate the find out the moment of inertia about y-axis is nothing but moment of inertia about y-axis of the top flange plus moment of inertia about y-axis of the wave and moment of inertia of about y-axis of the bottom flange. This is y3. So here it will be this is a simple rectangle. This is a simple rectangle section. A simple rectangle section. So moment of inertia about y-axis. It is a center of the whole all section. Center of the top flange. This axis passing through the center of each section. It means CG of each section. The CG of the top flange is this obviously half of the width. CG of the wave is equals to half of the width of the wave, and CG of the bottom flange is equals to half of the width of the bottom flange. So let me now calculate the moment of inertia about y-axis passing through CG. Passing through this is the CG. Not need to calculate the h1. Not need to calculate the y bar. Directly we can find out the moment of inertia about y-axis of the given section. So about y-axis equals to d bq divided by 12 for the section 1 is equals to d1 and b1. For the section 2 is equals to d2 into b2 cube divided by 12, and for the section 3 is equals to d3 into b3 cube divided by 12. To put the value of b1 d1 d2 b2 and d3 b3. So d1 is equals to d1 is equals to 12, b1 is equals to 8, d2 equals to 128, and b2 is equals to 12, and d3 is equals to 10, and b3 is equals to 128. Put all the value in this equation. So d1 is equals to 12 into b1 equals to 80 cube divided by 12 plus d2 equals to 128 into b2 equals to 12 cube divided by 12 plus d3 is equals to 10 obviously. 10 into b3 is equals to 128 cube divided by 12. 12 into 80 cube divided by 12, which is equals to 512 plus, calculate this part, 128 into 12 cube divided by 12, which is equals to 18432, and this one will be 10 into 120 cube divided by 12, which is equals to 14400 and 0. Add all this plus 18432 plus 512000. This is equals to 1.97 into 10 to the power 10 to the power 6 millimeter to the power 4. Now the polar moment of inertia of this section will be Ixx plus Iyy, which is equals to 12.45 into 10 raised to power 6 plus 1.97 into 10 raised to power 6. 1.97 into 10 raised to power 6 plus 12.45 into 10 raised to power 6 is equals to 14.42 into 10 raised to power 6 millimeter to the power 4. This is the answer. So the polar moment of inertia of I section is equals to 14.42 into 10 raised to power 6 millimeter to the power 4. Now calculate one more, now solve one more problem based on polar moment of inertia of different section. Let me choose a angle section. Angle section, this is the angle section. Find out the polar moment of inertia of this angle section. This is the size of this, let me consider 120 millimeter, and thickness is 10 millimeter, and let me consider this is 140 millimeter, and thickness is same as 10 millimeter, same as the flange. Calculate the polar moment of inertia. Polar moment of inertia. Polar moment of inertia. First we have to calculate, we need to calculate the CG of this section about x-axis and about y-axis. So find out the CG about x-axis, which is equals to y bar is equals to a1 y1 plus a2 y2 divided by a1 plus a2. Let me consider this is the section 1 and this is section 2. So area of the section 1 is equals to, area of the section 1 is equals to 120 into 10 is equals to 1200 millimeter square, and area of the section 2 is equals to, it is also 120, it is equals to 130 by 10, 130 into 10, 130 into 10 is equals to 1300 millimeter square. So CG about y-axis from the base of the section 1 is equals to y1. y1 is equals to 10 divided by 2 plus 130 is equals to 135 millimeter. And CG of the section, only section 2, 130 divided by 5, which is equals to y2. y2 equals to, this is y1 equals to 135, and y2 is equals to 130 divided by 2, which is equals to what? 65 millimeter. This is 65 millimeter. Now y bar is equals to area 1200 into y1 is equals to 135 plus area of the section 2 is equals to 1300 into y2 is equals to 65 divided by 1200 plus 1300. 1200 into 135 plus 1300 into 65 divided by 1200 plus 1300 is equals to 98.6 from the base, millimeter from the base. So this is the y bar of the whole section, whole angle section, is y bar is equals to this 98.6 millimeter. Now calculate the moment of inertia about x-axis. This is the x-axis, this is the x-axis. Let me first calculate the y-axis. Let me calculate the y-axis. So y-axis means x bar. CG of the y-axis is equals to x bar equals to a1 into x1 plus a2 into x2 divided by a1 plus a2. Let me draw once more of angle section. Small, I have to draw the angle section again. Now say this is section 1 and this is section 2. Now find out the x1 and x2. How can I find out the x1 and x2? Let me consider this is the axis. This is the axis, given axis. So x1 will be center of this rectangle. That means 120 divided by 2. This is equals to x1. This is equals to x1, and x2 is equals to center of this rectangle section, which is here. This will be x2. The x1 will be 120 divided by 2 is equals to 60 millimeter, and x2 is equals to thickness of the web of the angle section is equals to 10 divided by 2 is equals to 5 millimeter. Now calculate the x bar. X bar is equals to area of the section 1 is equals to 1200 into x1 is equals to 60 plus area of the section 2 is equals to 1300 into x2 is equals to 5 divided by 1200 plus 1300. 1200 into 60 plus 1300 into 5 divided by 1200 plus 1300 is equals to 31.4 millimeter from the given this axis. So this let me consider here the 60 here. This is the x bar. X bar is equals to 131.4 millimeter. Now the centroid of the whole section, which is x bar and y bar, coordinate of x bar and y bar is equals to 31.4 comma and y bar is equals to 98.6. This is the centroid of the section from the base. This is from the base and this is from the left side of the section. Now let me draw once more of the eye section of this angle section. Let me draw now. Now let me draw the eye section and point out the CG, point out the centroid of this section. This is the centroid coordinate of the point of the CG, centroid point of the eye section, which is coordinate of 31.4 comma 98.6. Now we have to calculate the moment of inertia, polar moment of inertia of this point. This is the y-axis and this is the x-axis. Now calculate the moment of inertia about y-axis, about x-axis. About x-axis equals to moment of inertia of x-axis section 1 xx1 plus moment of inertia of xx2. Now calculate the moment of inertia of flange section xx1 about x-axis is equals to moment of inertia of CG of this rectangle section plus area of this rectangle section 1 and h1 square. Now find out the h1. H1 will be from center of this section to the x-axis, which is equals to h1. The h1 is equals to y1 minus y bar. Y1 is equals to what? Y1 is equals to 135. We have calculated 135 minus y bar is equals to 98.6 is equals to 135 minus 98.6, which is equals to 36.4 millimeter. And H2, this is the section 1 and this is section 2. H2, center of the section 2, this is the H2. H2 is equals to y bar minus y2. Y bar equals to 98.6 and y2 is equals to 65 minus 65, which is equals to 98.6 minus 65, 33.6 millimeter. Now calculate the moment of inertia of rectangle section about the x-axis is equals to b1 into d1 cube divided by 12 plus a1 into h1 square. b1 is equals to 120 into d1 is equals to 10. 120 b, d is the thickness, 10 cube divided by 12, this is the 120 and this thickness 10, plus area of the section 1 is equals to, have calculate, we already calculated 1200 into h1 is equals to 36.4 square. One two zero into 10 cube divided by 12 is 120 into 10 cube divided by 12, which is equals to 10,000 plus 1200 into 36.4 square, which is equals to 1599952 millimeter to the power 4. For the section 2 will be 2 plus a2 into h2 square. Moment of inertia about CG of this rectangle section, b2 into d2 cube divided by 12 plus area of the section 2 into h2 square. b equals to what? b equals to 130. From this is total 140, and from here is 130 of depth, of the wave, and thickness of the wave is equals to 10, which is b equals to 10 and d equals to 130. b equals to 10 into 130 cube divided by 12 plus area of this section a2 is equals to, we already calculate it, 1300 into h2 equals to 33.6 square. This is equals to 10 into 130 cube divided by 12 plus 1300 into 33.6 square. This is equals to 3298481 millimeter to the power 4. Now calculate the moment of inertia of about x-axis of this angle section is equals to x x1 plus x2, ix1 plus ix2. This is 1599952 plus 3298481. This is equals to 4898433 millimeter to the power 4 millimeter to the power 4, or it is equals to, we can write 1 2 3 4 5 6, 4.89 into 10 to the power 6 millimeter to the power 4. Now calculate the moment of inertia about y axis. About y axis, we have calculated the moment of inertia about x-axis. So already it is complete to calculate the moment of inertia about x-axis. Complete. Now find out the moment of inertia about y-axis. I y y is equals to I y y 1 plus I y y 2. I am directly calculate it here. I y y 1 for this section 1, for this section 1, which is I C G 1 plus area of the section 1, area of the section 1 about y axis. This is about y axis, I C G 1 about y axis, and area of the section 1 into let me k1 square, k1 square from, and for the, this is the case 1, and for the case 2 will be I C G 2 about y axis plus a2 into k2 square. Now let me find out the k1 and k2. What is the k1 and k2? K1 will be center of the section about x axis, from the center of this section about x axis to this axis. Let me, this is the center is the 120, center is the 60, here to here, this is the k1. K1 is equals to, here I am right, k1 equals to x1, k1 equals to x1 minus x bar equals to x1 equals to 120, x1 equals to already I have calculated here, x1 equals to 60 minus x bar equals to 31.4, 60 minus 31.4, 60 minus 31.4, this is equals to 28.6 millimeter, and k2 will be center of the section about x axis. This is here to here, this distance is equals to k2. K2 will be x bar minus x2, x bar equals to 31.4 minus x2 equals to 10 by 2 means 5. This is equals to 31.4 minus 5, 31.4 minus 5 equals to 26.4 millimeter. Now calculate the moment of inertia about y axis of the angle section. Moment of inertia about CG of of the flange is equals to db cube, d1 b1 cube divided by 12 because it's y axis, plus a2 a1 into k1 square. This is the first case, and for the second case, d2b cube b2 cube divided by 12 plus a2 into k2 square. Put all the value in this equation. d1 equals to 10 and b equals to 120. 10 into 120 cube divided by 12 plus area of the section 1 is equals to 1200 into k1 equals to 28.6 square. The case 2, for the case 2, d2 equals to 130. This is d2 130 into b2 equals to 10 cube divided by 12 plus area of the section 2 equals to 1300 into k2 equals to 26.4 square. Now calculate it. I have right here. Here I will calculate this one and this one. This is the 10 into 120 cube divided by 12 plus 1200 into 28.6 square. This is equals to 2.42 into 10 to the power 6. 2.42 into 10 to the power 6 plus 130 into 10 cube 130 into 10 cube divided by 12 plus 1300 into 26.4 square. This is equals to let me calculate it again. 130 into 10 into 10 cube 130 into 10 cube divided by 12 divided by 12 plus 1300 into 26.4 square. This is equals to 0.917 into 10 to the power 6 millimeters 6 millimeter to the power 4. Obviously it will be millimeter. Now add this and this, sum it. 0.917 into 10 to the power 6 plus 2.42 into 10 to the power 6, 2.42 into 10 to the power 6 plus 2.42 into 10 to the power 6, 2.42 into 10 to the power 6. This is equals to 3.36 in 3.34 into 10 to the power 6. This is equals to 3 point, which is moment of inertia about y-axis is equals to 3.34 into 10 to the power 6 millimeter to the power 4. So moment of inertia, so the polar moment of inertia will be polar moment of inertia Izz equals to Ixx plus Iyy. Ixx equals to Ixx equals to 4.89 into 10 to the power 6, 4.89 into 10 to the power 6, and Iyy equals to 3.42 into 10 to the power 6. 4.89 into 10 to the power 6 plus 3.34 into 10 to the power 6 is equals to 4.89 into 10 to the power 6 plus 3.34 into 10 to the power 6 is equals to 8.23 into 10 to the power 6 millimeter to the power 4. This is the answer.